solving equations of logarithms, and we're going to go a little bit farther than we went yesterday. Today we're going to have it to where there are multiple logs on each side, or multiple logs on at least one side. And so, using that flow chart or that decision-making chart, it's going to help us figure out what we're doing each time. So, is there a single, we're going to go through each question as we're going through these. So, let's look at problem 1. We have log base 6 of x plus log base 6 of x plus 27 equals log base 6 of 58. The first question we had is there a single log, or is there more than a single log on each side? So is there more than a single log on one of the sides? Yes. So there is more than a single log on this side. We need to combine it. What operation am I going to use to combine those logs into a single log? Multiplication. So that's going to take these two items and we're going to multiply them. And so, because logarithms, remember when logarithms are separated with addition, the answer portion, which is what I've circled, gets multiplied. That's one of the laws of logarithms. And so we multiply those, we end up with x times x plus 27 equals log base 6 of 58. So in the next question, ask us, is there a logarithm on both sides? Okay, so if there is a logarithm on both sides, that means that we are going to set the inside piece equal to each other. What would be the answer if we were to convert this? And so when we set these equal to each other, I'm going to go ahead and multiply that through. Gives me x squared plus 27x equals 58. The next question I have, is there a squared variable? Yes. And that tells us to look to see, is there a b term? What was the b term?
6.
Whatever's multiplied times a variable by itself. So there is a b term. This is the b term. And so with that knowledge, I know I need to get everything to the same side. So how am I going to move the 58 to join everybody else? All the problems tonight, whenever you have to do these, I said you can either use quadratic formula or factoring. They will all be solvable with factoring. And so when we're factoring, that's where we use the boxes to help us. We had x squared, and we wanted to get negative 58. And so what two numbers multiply to give me a 58 that will give me a difference of 27? Well, half of 58 is going to be close to 27, so I will try half first. So 29. So 29 and 2. And we need to have one of them negative. Is the 29 or the 2 going to be negative? And David, you said it right. The 2 is going to be the negative one. So looking at our first row, what number or variable divides into both parts? An x. So I'm going to factor out an x. Looking at our second row, what number divides into both parts? Looking at our first column, what divides into both parts? Looking at our second column, And so that gives us the factors of x minus 2 and the x plus 29. Now that I have it factored, what do I do to finish solving this? Set your factors equal to and so x would have to be what in this first section? 2, because 2 minus 2 is 0. What would it have to be in the second one? So it seems like we're going to have 2 answers. Let's check to see, are either of those going to give us a negative when we plug it back up in that white circle I did at the first line. So up in those circles. So if I plug in a 2 for the x, will I get a negative in that spot? Will that become negative? If I plug in a 2 here, will I get a negative? Okay, so 2 is going to work for both. How about negative 29? If I plug in a negative 29 where that x is, will I end up with a negative in my logarithm? Yeah. So that means that one's not a possible solution. It is extraneous. So the only solution we end up with is just this one, even though 2 answers come out of it. So x equals 2 is our only solution. Problem 2. Log base 8 of a negative 4x plus log base 8 of 10 equals 3. So is there more than a single log on both sides? And so on this side, we have 2 logs. What are we going to do with the part I underlined? Combine them by doing what operation? Multiply, because they are separated with addition. So log base 8 of, if you want to do the math right now, it makes it easier. So negative 4 times 10 is?
Negative 40.
X. So all I did was multiply those 2 things to create that negative 40. Now at this point, do I have only a single log? And so since it's yes, then I need to use the fish to help me solve it. So that means it's going to be 8 to the power of 3 equals a negative 40x. Do I have a squared variable? Okay. So that means I'm just going to solve this like a regular algebra 1 linear equation. Except for we need to figure out what 8 cubed is. What's 8 times 8 times 8?
512.
Now we're going to divide both sides by the negative 40. And so x is equal to, what is 512 divided by negative 40?
Negative 64.
So if I was to replace the x back up in the original line, would I get a negative when I took negative 4 times a negative 64 fifths? No. I don't have to know what the number is, but I know it's not negative. Is there any other place I can plug it in that would create a negative in this? So this is my solution. The last question that we are going to work is, oops. Log base 8 of x squared minus 4 minus log base 8 of 4 equals 1. Do I have more than a single log on each side? So that means that we need to combine them. How am I going to be able to combine those two items? Divide. So log base 8 of x squared divided by minus 4 divided by 4 equals 1. And I typically put those in parentheses anytime I have more than just a single number afterwards. Now, what do I need to do? Do I have it to where there's logs on both sides? Since there's not logs on both sides, I am going to use the fish to help me solve. So 8 to the first power is equal to x squared minus 4 divided by 4. How can I get things moved around? Multiply by 4. So I can get rid of this 4. I'm going to multiply by 4 over 1 or 4 on both sides. That will cancel out there, and I'll get rid of the fraction. Now I have room to work. 8 to the first times 4 is going to be 32. Equals x squared minus 4. What do I need to do next? So now we're going to add that 4. And that gives us 36 is equal to x squared. So what could x be? 6? Is that the only number? Because we square root it. But could it be both of them positive 6s or both of them negative 6s? So it's plus or minus 6. So now we need to check, is a positive 6 and a negative 6 going to work in this situation? So let's go up to the top. If I have negative 6 squared, so negative 6 times negative 6, it'll be positive 36 minus 4. Is that going to be positive? If I have 6 times 6, 36, minus 4, it's still positive. So both those solutions, positive 6 and negative 6, work in this case. This is one of the two solutions.